Welcome to the Deep Dive. We cut through the noise to bring you what's important, what's interesting. Basically, your shortcut to understanding the big stuff.
And today, that big stuff is Onyx.
Onyx, right? A Layer 3 blockchain solution. We've been digging into their white paper, pulling out the key details for you.
That's the plan. Layer 3.
Yeah, Layer 3. So we know Layer 1s, like Ethereum, the base layer. Then Layer 2s came along, Arbitrum, based, those guys boosting speed.
Scalability fixes.
But Onyx is like the next stage. What's different this time? Is it just more speed?
It's definitely aiming for even more scalability, yeah. But it's also really focused on making different blockchains work together smoothly, interoperability, and doing it more cost-effectively.
Interoperability and efficiency. Okay.
Yeah, Onyx wants to be that super high-performance environment that we need for, well, the next generation of dApps, and maybe more importantly, for big institutions to actually jump in.
Institutional adoption.
Yeah.
Yeah, that's usually a sign something's trying to get serious. Okay, so our mission today, really get a handle on what Onyx is about, what makes it tick, why it thinks it's different, and, yeah, why institutions might be looking at it. Let's start simple. What is Onyx fundamentally?
So at its core, Onyx is a Layer 3 protocol, and it's built using Arbitrum Orbit.
Arbitrum Orbit, okay.
Which means it uses roll-up technology. Think of it like taking a whole bunch of transactions, squishing them together, processing them fast off the main chain.
And then posting the results back to a secure layer.
Yeah.
Standard roll-up stuff.
Exactly. And in Onyx's case, that ultimate security comes from Ethereum. But there's a twist.
Oh, so it's speeding things up, keeping Ethereum's security.
Yeah.
Like we saw with Layer 2s. But you said there's a twist. Base comes in here, too.
Precisely. Onyx adds another step. It actually uses Coinbase's base, that's a Layer 2, as its settlement layer.
Ah, okay. So not settling directly to Ethereum?
Not directly from Onyx, no.
Yeah.
This gives it another layer of economic security, another efficiency boost. So you've got Onyx doing the super fast transaction processing.
Right.
Then it settles onto Base. And then Base settles onto Ethereum.
Huh. A triple layer cake for security and speed.
Yeah.
Interesting. What's the main reason for adding that base layer in the middle? What's the core advantage they're going for?
The big idea is really pushing scalability without losing decentralization. Layer 1s can get clogged up, expensive.
Oh, yeah, we've all seen that.
And Layer 2s helped a lot, but they're often still quite general purpose. Onyx, being a Layer 3, can offer customizable execution layers. Imagine tailoring a specific blockchain environment just for one really demanding application.
Like you could spin up a version of Onyx just for, say, a huge DeFi protocol.
Yeah.
Or maybe an institutional trading platform.
Exactly that kind of thing. You could fine-tune the security, optimize the gas fees just for that app's needs, set up specific governance, all while still plugging into Ethereum's security and, its money.
And that's all powered by its own token.
Yeah, it has its own native gas token, Onyx Coin. The ticker is XCN.
XCN, got it. So it pays for gas. What else does it do? Is it just for transactions?
Oh, it's much more than that. It's really central. Yes, you use it for gas fees, running smart contracts, but importantly, people who hold XCN can stake it.
Stake it. Okay, so for rewards.
Rewards, yes, but staking also gives you voting rights in the Onyx DAO, the decentralized governance system.
Ah, so it's technical and political power, in a way. Community control.
Pretty much. It's about how the whole thing operates and evolves.
So it's not just faster, cheaper transactions. It's about building these bespoke environments and having community governance. Which brings us back to the basic question. Why Layer 3? I mean, why not just build a better Layer 2 or even a new Layer 1? What problem were they really trying to solve?
Fundamentally, it's about pushing the limits. Layer 1s hit ceilings, right? Layer 2s broke through a lot of those, but there's still this need for even more scale, especially if you want, like, millions of users.
Right, mass adoption scale.
Yeah, and you need more environments tailored for specific jobs, not just general ones. And smoother ways for all these different chains to talk to each other, all while keeping things secure and decentralized. Layer 3 just felt like the next logical step to try and crack all of that.
So Layer 2 was a big jump, but Onyx is saying, hold on, we can refine this more, we can specialize.
Exactly. Think specialization. Layer 1s, even Layer 2s try to do everything for everyone. Layer 3 lets you create these niche high-performance zones. Like you said, an institutional finance platform has totally different needs than, say, a decentralized Twitter.
Makes sense. Different tools for different jobs.
Onyx can build those different tools, these tailored roll-up chains for those specific needs.
And this modularity is key then, being able to pick and choose features, but still be anchored to Ethereum.
Absolutely key. You get the flexibility to optimize for your specific thing, but you still benefit from Ethereum's, security blanket and also liquidity.
Okay, so Onyx, customizable, fast layer 3, build using Arbitrum tech. But you called Arbitrum Orbit and Base a power duo. Why that specific combination? What makes them work so well together here?
It seems like a very deliberate choice.
Yeah.
Arbitrum Orbit gives them the toolkit to actually build and launch these custom layer 3 rollups. It's known for being scalable, cost-effective.
And it inherits Ethereum security, you said.
Right, that's crucial. Rollups built with Orbit get security from Ethereum.
And part of that cost-effectiveness is this AnyTrust thing. How does that fit in?
Yeah, AnyTrust is a clever part of Arbitrum Orbit. So normally, storing all the transaction data on-chain gets expensive. AnyTrust lets you store some of that data off-chain with a group called a Data Availability Committee, or DAC.
A DAC, like a trusted committee holding the data.
Sort of, but it's done in a way that minimizes how much you actually need to trust them. There are cryptographic guarantees. The main point is it drastically cuts down the data load on the main chain, which means lower transaction fees.
Okay, so the DACLs make it cheaper, but it's still verifiable. Got it. And then Base. What's its specific job in this duo?
Base comes in as that strong economic security layer. It provides scalability itself, good access to liquidity being tied to Coinbase helps there, and solid settlement guarantees.
And the Coinbase connection probably doesn't hurt for that institutional adoption angle either.
Exactly. Choosing Base for settlement feels like a clear signal they're serious about attracting institutional money and providing that extra layer of perceived safety and reliability.
So Arbitrum for the tech, the speed, the customization, Base for the economic security, the settlement layer.
You got it. And both are plugged firmly into the Ethereum ecosystem.
Which means things can move smoothly between Onyx, Base, and Ethereum. No awkward silos.
That's the goal. That tight integration is vital. It makes moving assets around, interacting across layers, much easier than if everything was totally separate.
Okay, the picture's getting clearer. Let's dive deeper into the mechanics. How does Onyx actually work under the hood? What are the key pieces of its architecture?
Right, so think of the layers again. Ethereum at the bottom for ultimate security, Base above that for economic security and settlement, then Onyx on top doing the fast execution.
Okay.
Now, inside Onyx itself, you've got the execution environment. This is where the transactions actually happen. It uses Arbitrum Nitro, which is great because it means it's fully compatible with Ethereum smart contracts, EVM compatible.
So developers don't need to learn a whole new language.
Exactly. And it uses an optimistic rollup model. Basically, it assumes transactions are okay unless someone proves otherwise.
Optimistic, right.
Yeah.
Faster. But you need a challenge mechanism.
Yep, they have fraud proofs. If someone spots a bad transaction, they can challenge it and get it corrected. It's generally faster and cheaper this way.
Okay, execution environment using Nitro, optimistic rollups, fraud proofs. Then the data availability layer. That's where AnyTrust and the DASCII come in.
Correct. Keeping data accessible off-chain to keep costs down, but still verifiable. And then the settlement layer, that's Base, like we discussed, providing that finality step before it all gets anchored back on Ethereum L1.
Got it. And powering all this is the gas token, XCN. You mentioned EIP 1559.
Yeah, so XCN is the fuel. And implementing EIP 1559 is a big deal. Remember how that changed Ethereum gas fees?
Made them more predictable and it burned some of the fee, right?
That's the one. Onyx does something similar with XCN. There's a base fee that goes up or down with network traffic. Plus, you can add a tip for priority. And crucially, part of that base fee gets burned.
Burned, so removed from circulation. That could make the token deflationary over time.
Potentially, yeah. It ties the token's economics directly to network usage. It's not just about paying for a transaction. It affects the token's supply dynamics.
Interesting. Okay, what about pure speed? How do they get high throughput? You mentioned execution efficiency.
So the optimistic rollup model helps because you can batch lots of transactions together. But they also have a high-performance sequencer that's the component that orders the transactions efficiently before batching. Plus, they use advanced compression techniques to shrink the data size before it gets sent down to Base and Ethereum. LEC data equals lower cost and faster processing.
And if someone does cheat, the fraud proofs.
Right. There's a delay window before transactions are totally final, giving time for challenges. And if there is a dispute, it uses this multi-round interactive process to figure out who's right. It's designed to be robust.
Sounds thorough. Okay, let's quickly revisit data availability with AnyTrust. You mentioned the DAC.
Right, the Data Availability Committee holds the data off-chain. They use Merkle trees and hash commitments. Think of them like digital fingerprints, so anyone can check the data's integrity quickly without needing the whole data set.
And if the DAC messes up or it goes offline?
There's always the fallback. The data can still be posted and retrieved directly from the layer below, ultimately Ethereum if necessary. So the security isn't solely reliant on the DAC.
Good safety net. Okay,
Yeah.
settlement on base L2. How does that final step work before Ethereum?
So Onyx bundles its processed transactions and sends them down to base L2. Base is also an optimistic rollup, remember?
Ah, right. So base has its own fraud proofs and finality delay.
Exactly. Base validates the batch from Onyx, runs its own checks, has its own waiting period, and then finalizes those transactions onto Ethereum L1. Like Onyx, Base also uses batching and compression to keep its own fees low. It's like an efficient pipeline down to the main chain.
Layers upon layers of optimization. Now back to the custom gas token .xcn. What's the real benefit of using XCN instead of just, say, ETH for gas on Onyx?
Flexibility mainly. Using XCN allows Onyx to potentially offer lower, more stable fees on its own network, shielded a bit from Ethereum's gas price swings.
Okay, more predictable costs for users on Onyx.
Yeah, and it also unlocks application-specific fee stuff. Imagine a game built on Onyx wanting to maybe subsidize gas fees for its players. Easier to do with your own token.
Ah, interesting. Custom fee models.
Right. Plus, the EIP 1559 mechanism, the base fee, priority fee, the burn, that all directly impacts XCN's own value and economics. And they're looking into things like gas abstraction.
Gas abstraction, like hiding gas fees from the user.
Sort of, yeah. Or fee delegation using meta transactions.
Oh.
Basically ways to make using the network smoother, especially for people who aren't crypto natives. Pay gas in USDC maybe, or have an app pay it for you.
That could definitely lower the barrier to entry. Okay, last architecture bit. The white paper lists a bunch of core smart contracts. Roll up, inbox, outbox. Do we need the details on all of these?
Probably not individually, no, but it's good to know they exist. Think of them as the specialized engine parts. You've got the main roll-up contract managing the whole process. Inbox and outbox handle messages moving between Onyx, Base, and Ethereum.
Okay, communication channels.
Right. Admin proxy for controls, utilities for helpers, validator wallet creator for the network validators, L3 upgrade executor for smooth updates, gateways for moving different kinds of tokens across the layers. Multi-call lets you do multiple things in one transaction. Proxy admin helps manage contract upgrades securely. The router directs traffic.
So a whole suite of specialized contracts working together.
Exactly. They each have a specific job to keep the whole Onyx Layer 3 running smoothly and securely.
That gives us a solid technical foundation. Now let's really focus on Onyx Coin XCN. We know it's gas, but you said it's much more. Tell us about XCN staking.
Absolutely. So paying for stuff is just one part. Staking XCN is crucial for the network's health and direction. You stake your XCN, which actually happens on the Ethereum blockchain.
On Ethereum, not on Onyx itself.
Right. The staking contract lives on Ethereum. Doing this does two main things. One, it gives you voting power in the Onyx DAO, the governance system.
Yeah, influence.
And two, you earn staking rewards. These rewards come from a dedicated smart contract, basically incentivizing you to lock up your XCN and participate in securing the network's value and governance.
And I think the white paper said no mandatory lockups. That seems unusual for staking.
It is quite flexible, yeah.
Yeah.
Unlike many systems where you have to commit for weeks or months, here you seem to have more freedom to stake and unstake. It lowers the barrier to participating.
And rewards are based on how much you stake.
Yeah, it's calculated based on the total reward pool available for a period and your share of the total XCM being staked across the whole network. Pretty standard proportional reward system.
So staking rewards plus a voice. Let's talk more about that voice. XCN governance via the Onyx DAO. How does that actually work? Can anyone propose changes?
Well, anyone who holds and stakes XCN, yes. They really put the token holders in the driver's seat. You can submit proposals on-chain for, protocol upgrades, changing economic parameters, even deciding how treasury funds are spent.
And voting power is tied to how much you've staked.
Exactly. More staked XCN means your vote carries more weight. It aligns influence with economic commitment to the network.
Makes sense. What's the process like? From proposal to actually happening?
It's pretty structured. You need a certain amount of staked XCN just to make a proposal, preventing spam. Then there's a voting period, looks like 3 days, where other stakers vote yes, no, or abstain.
Okay. And does it need a majority? Or?
It needs to hit two things. First, a minimum total number of votes need to be cast, showing enough people are engaged. Second, an approval threshold the white paper mentions needing at least 200 million XCN votes in favor.
200 million XCN. Okay, so if it passes,
If it passes both checks, it doesn't happen instantly. It goes into a 2-day time lock period.
a waiting period. Why?
It's a safety measure, gives everyone a chance to see what's about to change, prepare, or even raise alarms if something seems wrong. After the time lock, the execute function can be called, and the change gets implemented on the protocol. Helps prevent rash decisions.
That time lock seems smart. Okay, let's zoom out to the XCN tokenomics and distribution. Is there a limited supply? How does it get into circulation?
Yeah, there's a fixed maximum supply for XCN, which is important for scarcity. They track and report the total versus circulating supply. And we already mentioned the burn mechanism through gas fees.
Right, potentially reducing the supply over time.
Exactly. New XCN emission is controlled carefully through on-chain and off-chain methods, aiming for a predictable release until that max supply is hit. And remember, XCN starts as an ERC20 on Ethereum.
But it needs to get to Onyx and Base, and you mentioned Binance Smart Chain too.
Right, so bridging is key. They use technologies like Superbridge and Wormhole to move XCN around. When XCN is bridged, say, to Base, the original Ethereum token is locked and a wrapped version is created on Base. It maintains the 1.1 value and respects the overall total supply limit.
And part of that total supply is held in an Onyx treasury. What's that for?
Yeah, a chunk is set aside for the treasury. And importantly, the DAO, the XCN stakers, governs this treasury.
So the community decides how to spend it.
Exactly. It can be used for things like ecosystem grants to attract developers, liquidity incentives to make trading XCN easier, funding core protocol upgrades, or even strategic partnerships. It's fuel for growing the ecosystem directed by the token holders.
So XCN really is woven into everything: utility, security, governance, funding. Now, you mentioned XCN bridging and cross-chain transfers again. Let's quickly cover how that works. Wormhole and Superbridge.
Right. Since XCN lives natively on Ethereum as an ERC20, you need bridges to use it elsewhere. For getting XCN over to Binance Smart Chain, BSC, they use Wormhole.
Wormhole, okay. How does that one work?
It's typically a lock-and-mint system. You send your Ethereum XCN to a Wormhole contract, it gets locked there, and Wormhole issues a corresponding wrapped XCN token on BSC. To go back, you burn the BSC token and unlock the Ethereum one.
Got it. Lock on one side, mint on the other. And for Base and Onyx itself, that's Superbridge.
Yeah, for moving between Ethereum, Base, L2, and Onyx, L3, they use Superbridge. It's designed specifically for this kind of roll-up to roll-up or roll-up to L1 transfer within the Ethereum ecosystem. It's meant to be faster and cheaper for these specific routes.
Makes sense to use a specialized tool for those internal transfers.
Definitely. It makes moving XCN to where you actually need it, like paying gas on Onyx, much more seamless.
So these bridges are crucial for liquidity, right? Letting XCN flow where it's needed for DeFi or just paying fees without being stuck on one chain.
Absolutely. It connects Onyx to the wider DeFi world and makes XCN genuinely useful across its different layers of operation.
Okay, great tech, central token. But who's actually using Onyx? What does the Onyx ecosystem look like right now? Are people building on it?
It seems they're putting effort into making it developer-friendly. They're using something called Conduit.
Conduit, what's that?
It's like a roll-up as a service provider. Basically, it helps streamline deploying roll-ups and integrating all these different ecosystem parts, makes it easier for partners to plug in.
Okay, so making onboarding smoother. Who are some of these partners?
Well, there's Privy. They focus on secure data management things like easier user logins, encrypted storage, even zero-knowledge proofs for privacy. Important for dApp security.
Privacy and security tools, check.
Then you need stablecoins, right? So Bridged USDC is there to provide that core stablecoin liquidity, essential for any DeFi activity trading, lending, collateral.
Can't have DeFi without stables.
Yeah.
And Superbridge, we covered moving assets. What else?
For developers, there's Tenderly. They offer tools for monitoring smart contracts, debugging them, optimizing gas usage, basically helping devs build better, more efficient dApps on Onyx.
Developer tooling, important.
And ThirdWeb, that's another big developer toolkit. Provides pre-built smart contracts, tools for managing NFTs, tokens, maybe even enabling gasless transactions for users. Speeds up development time.
Okay, making it easier to build things.
Then there's Decent. They focus more on the digital asset creation side, NFT infrastructure like multi-chain minting, maybe tools for marketplaces, and even tokenizing real-world assets, RWAs.
RWAs. Interesting. That's a hot area.
Definitely. And the white paper made a point about the synergy with chain. What's that relationship?
Yeah, chain. They provide blockchain infrastructure, often for financial services, right?
Exactly. And the idea is that Onyx, with its layer 3 speed and low fees, can seriously boost chain's offerings. Think faster settlements, cheaper transactions for their clients, scaling up asset tokenization.
So Chain could use Onyx as an underlying layer for some of its products.
Precisely. Better DeFi integrations for their clients too. And Chain might even deploy its own permission subchains on Onyx for specific enterprise needs. It shows Onyx isn't just aiming for new dApps, but also upgrading existing financial tech players.
That's a strong signal. Using Onyx to enhance established financial infrastructure,
Yeah,
that definitely plays into the institutional adoption narrative.
it does. It positions Onyx as a potential backbone for a wide range of uses, from pure DeFi up to large institutions.
This is all building a pretty compelling case. What's next? What does the roadmap look like? Where are they focusing future development?
The roadmap has some really interesting, ambitious goals. One area is decentralized physical infrastructure networks, DePINs.
Depends.
Yeah.
Like blockchain for real-world devices, IoT, sensor networks, that kind of thing.
Exactly. They see Onyx potentially acting as a super efficient settlement layer for all the data these networks generate, maybe handling tokenized incentives for people running nodes in, say, a decentralized Wi-Fi network.
A layer 3 seems like it might actually have the throughput for that kind of data load.
That's the hope. Scalable data settlement for real-world applications. Another big focus is subchains for permissioned interoperability.
Subchains,
Mm.
like mini blockchains running on Onyx.
Kind of, allowing enterprises to deploy their own dedicated chains tailored to their specific compliance or performance needs, but still able to securely interact with the main Onyx network or other subchains.
So private chains that aren't totally isolated, that could appeal to regulated industries.
That's the idea. Best of both worlds, potentially. Customizable consensus, modular design, and then there's artificial intelligence.
AI integration. How does AI fit into a blockchain like Onyx?
This is pretty forward-looking. They're exploring using on-chain AI for things like optimizing smart contract execution, maybe AI spotting potential risks or fraud patterns faster,
Oh, okay.
even potentially decentralized AI marketplaces built on Onyx, or AI helping with DeFi portfolio management, or predictive scaling using AI to anticipate network load and adjust resources proactively.
AI and blockchain working together. That opens up a whole new set of possibilities. Very ambitious. Anything else major on the roadmap?
The final big area is continuous performance improvement, parallel processing, and high-throughput enhancements. They're looking at L3 specific state sharding, optimizing the sequencer even further, maybe even enhancing the core virtual machine Onyx runs on.
So basically making it even faster and able to handle even more transactions.
Always pushing the envelope on performance and scale. It's not just about small tweaks. It's about fundamental improvements to handle future demand.
Well, that was definitely a deep dive. We've covered a lot of ground on Onyx. Let's try and boil it down to the key takeaways for everyone listening.
Yeah, okay. So in a nutshell, Onyx is positioning itself as a leading-edge Layer 3. It's built on solid tech Arbitrum Orbit for the framework, based for settlement security, all anchored to Ethereum.
And its main goals are pushing scalability, keeping costs low, and making different chains work together, better interoperability.
Exactly. It uses clever tech like AnyTrust for data availability to help with costs. And its native token, XCN, isn't just for gas.
Right. XCN is central. It's for utility, paying fees, but also critical for staking, earning rewards, and participating in the decentralized governance through the Onyx DAO.
Definitely. And Onyx isn't shy about its ambitions. There's a clear focus on attracting institutional adoption alongside powering new dApps.
And that's backed up by a growing ecosystem of partners Privy, Tenderly, Third Web Chain, and a roadmap looking at future tech like DePINs, AI integration, and constant performance boosts.
It paints a picture of a platform trying to build for the future, tackling some of the big challenges in blockchain today.
So as we wrap up, here's something to think about. How might these Layer 3 solutions like Onyx really change the game if they deliver on this promise of massive scale, customization, and interoperability? What new kinds of applications become possible? What industries could be transformed?
Yeah, think beyond just faster DeFi. Think about supply chains, real-world asset tracking, maybe even decentralized social media that can actually handle millions of users smoothly.
The potential is huge. Maybe it's worth digging into their white paper yourself if this sparked your interest. Lots to consider. Thanks for joining us on the Deep Dive.